Hello and welcome to the second video of vector algebra. In this video, we will be covering vector addition and subtraction and vector position and distance. So how to add two vectors? Well, let's say we have a vector A and vector A has a component in the x direction and a component in the y direction and a component in the z direction. And we have a vector B, which has a component in the x direction, a component in the y direction, and a component in the z direction. And we want to find vector C, which is equal to A plus B, vector A plus vector B. Well, we just add the like components, similar like components. So vector C would equal to we add the components of the x together. So ax plus bx multiplied by the x unit vector plus ay plus by with the y multiplied by the y unit vector and the az plus az plus bz multiplied by the z unit vector. And it's as simple as that. That's algebraic. But let's say we want to find vector D, which is A minus B. Well, instead of adding them together, we just subtract them. Very simple. Adding and subtracting vectors is the easiest thing you can do. So we say ax minus bx multiplied by ax unit vector plus ay minus by multiplied by ay unit vector plus az minus bz multiplied by az unit vector. It's as simple as that. But if we want to do it graphically, we say we have a vector. Let's call this vector A, and this vector B. Vector C will be the resultant vector in between them, and that would be C is equal to A plus B. However, how will we do D, which is equal to A minus B? Well, essentially, A minus B is equal to A minus plus B. Oh, I'm sorry. A plus minus B. So what we can do is write the normal vector A now minus B is equal to B but at the opposite direction. So it will go downward and D will just be equal to this. That would be D. This would be A and this would be minus B. We do have some laws for addition. The first thing is that it is commutative. Commutative. So A plus B is equal to B plus A in vector addition, because in vector multiplication, that's not the case. Associative. It is also associative, which means A plus B plus C is equal to A plus B in parentheses plus C. So when adding vectors, the order of addition doesn't really matter. And it is also distributive. So if we have constant K multiplied by A plus B, you can distribute that constant. So Ka plus Kb. That's when adding vector. There's also multiplication, but this multiplication is not for vectors, it's for scalars and vectors. It is only commutative. We have K multiplied by vector A is also equal to vector A multiplied by K. And if we have a second constant L multiplied by constant K times vector A, it is equal to L multiplied by K multiplied by the vector. That's the only thing for multiplication in this case, which is scalar multiplied by a vector, not vector multiplied by another vector. When we multiply two vectors together, that's a whole different topic in the second video. So we have this thing called position and distance vector. A position vector says we have point B in space. There will be a vector that links that point with the origin, and this vector will tell us the position of that point in space. Hence the name position vector. So let's say we have a point P in space. By the definition of the position vector, we will know that there will be a vector that links that point with the origin, and that vector will be called RP, hence the position vector. RP will be expressed as x ax plus y ay plus z az. The x and y and z are the coordinates of the point P. The distance vector states if we have a second point, we will call it point Q. there will be a vector that links point P to point Q. So point P to point Q is a second vector, and this vector will be called RPQ. Now, RPQ is equal to RQ minus RP. The Q is subtracted from the P. Take this as a note for the rest of your life in anything, in electronics, in electromagnetics, or in anything. If you have, for example, VAB, it is equal to VB minus VA. Does the order of points matter in this case? The answer is yes. You might have heard, if you want to find the delta of anything, you take that something's final and subtract it by the initial. It's the same thing in here. Point B, the vector starts at point B and it ends at point Q. Hence, RQ minus RP is from RP to RQ, hence RPQ. If you did RP minus RQ, you would get the same answer, but at the opposite direction, which will be the negative of that answer. And that will be wrong in this case, because in here, the negatives are important. A second note is that the position vector is a special case of the distance vector. If you haven't noticed, if we want to find the distance vector of point B with the origin, so RPO will be equal to, ROP is equal to RP minus RO. All of these are vectors. Now, RO is at the center, it's at the origin. This is equal to 0. So it will be equal to RP only. Hence, the position vector is a special case of the distance vector. Now, let's apply what we have applied at subtraction to this formula. We will get xq minus xp ax plus yq minus yp ay plus zq minus zp az. And this is equal to this. Of course, zq is the coordinate, xq, yq, zq are coordinates of x, y, and z of q. And xp, yp, and zp are the coordinates of x, y, and z of p. Now let's take an example of what we have explained before about subtraction and the addition. Let's say we have a vector A with a component of 10 to the x direction minus 4 to the y direction plus 6 to the z direction. And vector b, the component of 2 to the x direction plus 1 to the y direction. If there are no components next to the unit vector, that is equal to 1. If there's an addition sign, then it's plus 1. If it's a negative sign, then it's minus 1. And it asks you to find A, the component of A along AY. B, the magnitude of 3A minus B. And for C, the unit vector of A plus 2B. Don't forget the vector sign. It is important. So the component of A along AY is a very easy answer. But before all of this, try to solve it by yourself and then come back, look at the answers. It will help you a lot. It will tell you what you are good at and what you're bad at, and what you understand and what you don't understand. So the component of A along AY, is this. So AY is equal to minus 4. It is not 4, it is minus 4. Don't forget the minus sign. Now for B, magnitude of 3AB. First of all, what is 3A? 3A. It is essentially a scalar with a magnitude of 3 multiplied by the vector A. You distribute the 3, so it becomes 30 AX minus 12 AY plus 18 AZ. Now subtract this from B, which is this. It will get you all of that minus 2AX plus AY. So let's do 3A minus B here. 30 minus 2 multiplied by the x unit vector plus minus 12 minus 1 minus 12 minus 1 AY plus 18 minus 0 A, A Z, which will be equal to 30 minus 2, that is 28 AX minus 12 minus 1 minus 13 AY plus 18 AZ. There you have it. That's 3a minus b. But that is not the final answer. If you have gotten here, that's fantastic. But that's not the answer. They want the magnitude of 3a minus b. So 3a minus b, and that is the square root of 28 squared plus 13 squared plus 18 squared. Let's bring the calculator and see. 28 squared plus 13 squared plus 18 squared, and that is 35.73. 35.73. And there you have it. That's the magnitude of 3a minus b. Now for c, we need to find the unit vector of a plus 2b. Well, let's start with finding the value of 2b. 2b or not 2b? Don't dislike the video, please. 2 is a scalar multiplied by a b vector. You just distribute the scalar. So 2 times 2, that is 4ax. 2 times 1, that is, well, 2 times 2. 2 times 1, it is 2. ay. So let's add it to a. 10 plus 4 ax plus 2 minus 4, 2 plus minus 4 ay plus 0, 6 plus 0 a z. And that will give us 10 plus 4, that is 14, ax, 2 minus 4, that is minus 2, ay, plus 6 az. That is the value of a plus 2b, but that's not the final answer. The final answer is the unit vector of a plus 2b. And let's call this c to make things easier for us. The unit vector of c is equal to the vector c divided by the magnitude of c. First of all, we need to find the magnitude of c. So let's do it here. 14 squared plus 2 squared plus 6 squared. 14 squared plus 2 squared plus 6 squared under the square root is equal to 15.36. 15.36. So the vector c, 14 ax minus 2 ay plus 6 az divided by 15.36. And this will give us 0.9113 ax minus 0.1302 AY plus 0.3906 AZ. And this is the final answer. Let's highlight it in yellow. This is the final answer for B. Final answer for A. How will you prove that this answer is actually correct for the unit vector? Well, if you remember the definition of the unit vector says that it has a magnitude of 1. So let's take the magnitude of all this. The magnitude of 0.9113 squared plus 0.1302 squared plus 0.3906 squared. If you plug in that into calculator, it should give you 0.1302 squared plus 0.3906 squared. And I'm going to show you my calculator. It is 0.9999959. I'll take that as a 1. It's pretty close to 1. So it's safe to put all that equal to 1. And this will tell you that your answer is true. I want to take a second example. So there is a point P, which has the coordinates of 0, 2, and 4. And point Q, which has the coordinates of minus 3, 1, 5. I cannot write the number 3. And they want us to find the position vector of P. Position vector of P. They want the distance vector from P to Q. They want to see the distance between P and Q. And last, they want a vector parallel to PQ with magnitude of 10. Okay, these are all great questions. And let's start with A. Again, pause the video, try to solve these by yourself, come back and look at the answer. Giving them a shot by yourself is a great boost. So, position vector of P, R, P. If you remember, what would that equal to? It would equal to X, AX plus Y, AY plus Z, AZ. And in this case, it is 0 AX plus 2 AY plus 4 AZ. That is the position vector for P. Now B, the distance vector between the distance vector from P to Q. So they want us to find R, P, Q. And that is equal to R, Q minus R, P. If you got this, then fantastic. You are on the right track. RQ is equal to minus 3AX plus AY plus 5AZ. And we already have RP. All you have to do is subtract them. So this will be equal to RQ minus RP. So minus 3 minus 0 AX plus 1 minus 2 AY plus 5 minus 4 AZ. And this will give us minus 3 AX minus AY plus AZ. And that is the final answer for section B. Now the distance between P and Q. Well, let's think about this. We found the distance vector and they want us to find the distance. In other words, they want us to find the magnitude of the distance vector, because that would be the distance between P and Q. If we have this here, point P, and this is point Q, and we found the vector. The magnitude of this vector, how tall this vector, that is the magnitude of the vector. So the distance RPQ will be equal to the square root of 3 squared plus 1 squared plus 1 squared. That is 9, 10, 11, square root of 11. That is a weird one. So now to number D, section D. A vector parallel to PQ with a magnitude of 10. Let's think about this one. We have vector PQ, which is RPQ. It's the same one. There is a parallel vector to it. What is a parallel vector? A parallel vector is a second vector that has the same direction to our vector, but they never touch. They both go to the same direction, but they never cross each other. That's the parallel. Ever. But it has a magnitude of 10. Now a vector has a magnitude, let's call this vector A. Now vector A has a magnitude and a direction. We already know that this will be equal to 10, but we don't know the unit vector. And they want us to find the main vector. They want us to find this parallel vector. Because it is parallel, we know it has the same direction to this, and the direction translates to the unit vector. So if we find A, R, P, Q, it should be equal to A. So let's start with this. So A R P Q, A sub R sub P Q. We know that that is equal to R P Q as a vector divided by the magnitude of R P Q. Now, luckily, we knew have this. We already found it, which is this. So RPQ is minus 3AX minus AY plus AZ divided by the magnitude, which is square root of 11, if I'm not wrong. This will be equal to ARPQ. I'm going to keep it as it is. Let's scroll down. Okay. And this will be equal to AA. So A is equal to 10 multiplied by this. So 10 multiplied by minus 3AX minus AY plus AZ divided by the square root of 11. If you want to distribute it, it's fine. So we can say minus 30 AX divided by square root of 11 minus 10 divided by the square root of 11 AY plus 10 divided by the square root of 11 AZ. And there you have it. A vector that has the magnitude of 10 and is parallel to RPQ. I hope you understand. I hope you understood everything that is in this video. If you have any questions, comment it down below. I will try my best to answer them. And leave a like on this video if you enjoyed it. Share it with anyone who needs help with this subject. That would be a great help for me. And thank you for watching.